Hello, I'm Chris Athanas. I'm a KMP developer. Tech support's coming out Tuesday to close that guy up. Hopefully, we'll see. We're doing a little rundown about adventure-driven development, and then I'll have the lead do in the description box thing down there. I'll have a link to this. But we're gonna go through some people that I know were inspired by adventure when they were doing their stuff. They were on an adventure. They didn't really care about money or fame or fortune. They were trying to do something that they wanted to do. All right, and for their own internal reasons, right? That don't often don't make sense. But what we're trying to do is align this type of personality thinking with a development cycle, and it's totally a thing. It's definitely a lot of the stuff that we use today. The computer you're on right now was, if it wasn't for this guy that I'm about to show, we wouldn't have Unix, we wouldn't have C, we wouldn't have assemblers and things that we take for granted. We'd still be working on mainframes because there was nobody that was thinking these ways. Okay, here we go.
What about the people, the naysayers, when you go to tell them, you're not going to Goldman Sachs, you're starting a business. Someone tells you that you can't do it or they have all these doubts. What does that mean?
Well, that means that they can't do it themselves. Like everybody says you can't make money in Santa Barbara. Santa Barbara's the best place to make money. I live there. They've got mountains and ocean, a thin layer here. Very wealthy people, a university that create a lot of stuff, and real estate prices that, not going anywhere. You got to have a utility here. How much Bakersfield is there? There's a lot of Bakersfield. Every time you build something here, there's another piece of somebody building another Bakersfield. If you can't make it in Santa Barbara, you can't make it anywhere. But everybody says, oh, I can't make it in Santa Barbara. Baloney. That means that they can't make it themselves in Santa Barbara. You can make a good living any of these places. You got wealthy people with ideas. What do you have in Bakersfield? A bunch of cows?
Okay, that wasn't Ken Thompson. That was Paul Orfalia. He's a guy that was in Kinko's. But the point of that is, when people say you can't do it or you shouldn't do it, they're because they can't do it themselves. That's really the sad story. One of the things I've noticed is that when people are talking, they're really just talking about themselves. So when I'm talking about all this stuff, I'm just talking to myself, and it just kind of feels that way. And so, yeah, when somebody says you can't do something, that's because they haven't seen the vision or see it how you see it. So let's look at where this technology. This is Ken Thompson and Dennis Ritchie's. This is about those two guys. So Dennis Ritchie did see. He very clever guy. Very. Both of these guys are concentrated, simplifying thinkers who are trying to refine something down so they can get something done themselves, right? And that's the kind of the spirit of thing. It's not actually what we can do a lot of times with adventure-driven development, but that's the kind of the spirit of things. Like, what can we do with what we got to try and do it? So it's like cutting stuff away. So that's a lot of what goes on, as opposed to at the time, which is adding stuff on, which is adding on, becoming more and more proprietary, more and more locked in. And let's go into it.
A computer is a state machine. Basically, all it is do something and then find the next state to go to. What really goes on underneath is certainly not realized.
When you look at the ocean surface, it's hard not to be mesmerized by it. But what we don't often think about is how much of that surface is influenced by a myriad of invisible processes, all happening just underneath. Similarly, computers rely on countless calculations working internally, so you can jump from your web browser to your email to the game or music player you have on in the background. The computer, as the machine we know today, would not be possible without UNIX.
In the days before Unix, computers were massive things, roomfuls of things. A single computer does a single thing at a time, and very, very expensive. Suddenly, there was a mini-computer revolution.
It took the insight of two bright computer scientists, Ken Thompson and the late Dennis Ritchie, who, with very different but complementary skill sets, were able to put their heads together and launch what would become the forerunner of the modern-day operating system.
Unix was built for me. I didn't build it as an operating system for other people. I built it.
That's it right there. He built it to do games and because he's on his own adventure. So he built this system for himself that just happened to coincide with about a million other guys, a million other people that were trying to do the exact same thing, and were super frustrated by this batch nature of the computers that were there. They were super expensive, and you had to have a key access code. Everyone was behind locked doors. No one can't get in. And these guys are like, no, that doesn't seem right. At least doesn't seem right to me. And that is where this stuff came out of. It was not a top-down thing. It wasn't some committee in some big organization that said, oh, it would be a pretty good idea if we did Unix and made a simplified language that allowed all these microprocessor manufacturers to do all their crazy stuff and still have the same one piece of software run on all of them. And it doesn't matter what kind of crazy thing to do. This will be this universal translation layer. They didn't come from them. Whoever thought that that came top down is completely loopy, and they're just missing a major part of computer history and how this stuff actually comes into existence, how it actually comes into existence. These kinds of people, these super nerdy people who are on their own mission for their own reasons, that has very like slightly adjacent goals that they could. That what happened was they found a way to sneak in to these organizations and wedge their way in by hook or by crook to get onto these, to get their what do they wanted to do? Games. They wanted to write games. They wanted to play games on these things. This was their main goal imperative, their driving goal, and there was nobody else doing it. They were still trying to do this batch processing stuff. Oh man, it was just a mess. It was just so frustrating to be like, I want to have time on these machines. People say, no, you have to get right access. So that's that, and then it leaked out, right? It was just such a compelling thing that people wanted to do, to have time on their own machine, that's what created the revolution that allows us to have our machine available. This guy here, these two guys.
To do games and to do my stuff. I was always into games. Games was my thing. I used to play pinball machines, and I would pick the lock in the back of the pinball machines. Then I'd study the diagrams that I had.
So that's the kind of person this is. He likes to go into the weeds. He's a technical guy, and he goes into the weeds. He's playing. This is playing, right? This is all play, right? This is adventuring for its own sake, for its own purpose, just for the pleasure of knowing how this stuff works and how it's all put together, and let somebody else experience it, maybe it too. Totally different, a whole different mindset, completely different mindset than most of the people on the time that were doing. And you would never be allowed to do a pinball machine on a batch mainframe. No. I mean, one of the guys that runs it might. Like, he runs in the computer room, like, we'll sneak his little program on there. But in general, no. This is for serious work, for counting, for machine, for CAD design, and for, all that stuff. Not for dinking around with toy games. What are you doing? Now it's like a huge business, and it wasn't for him. It wouldn't exist.
That's where I learned a lot of this kind of logic. I pretty much did the initial Unix work. Then when Unix was up and running on a PDP-7, Dennis came along and started writing programs with me.
A trashed PDP-7. This was not sanctioned. This is something these guys were kind of go off and do on their own. They somehow justified it with their boss, and they were just kind of on their own making games. And then in the meantime, also making an operating system and a portable language and an assembler that could work on all kinds of different processors. And at the same time as they were doing this other goofy stuff, right? So this is where the adventure can lead, and they can break through these kinds of technologies, these techniques, these markets, the things people wouldn't expect.
On it.
I would describe Dennis Ritchie as an exceptionally nice guy who sort of may come across shy, but inside he was one of the kindest, most giving people I've met in a long time.
He was sharp. He was much more mathematical than I. Once he got an idea, he was almost bulldog. He just worked on it until it happened.
Yeah, because he's trying to do this. He's getting down in the weeds too for his own reasons, right? I don't know exactly the reasons are, but I'm sure it's games. I'm sure it has something to do with some games.
Worked very, very closely for very many years.
There was one point where they each wrote a piece of code to do something, some small library function kind of thing, and when they compared their versions, they were essentially identical. So their thinking processes were very, very similar.
Sometimes inventions come from an individual's pursuit to push the limits of existing technology for their own use. Often, this pursuit ends up benefiting us all. Together, Thompson and Ritchie eclipsed existing limits to develop UNIX, and their work has given us access to a dimension that existed inside the computer from the very beginning, one that now lives on as their legacy, always lying just beneath the surface of our everyday lives.
There's no user in Unix. There's no third person. It's first person. It has no more than it needs. It just does what it's supposed to do. I think that's the difference between Unix and operating systems before Unix.
Yeah, for sure. Yeah, so he blew it away. So here's Ken Thompson, and this is a Spanish channel that's doing this, so that they. That's why it's in Spanish here, but I'm going to do subtitles in English as well. But it's him telling his story about why he got into this stuff.
Ken Thompson, I am known for writing Unix in a previous lifetime. My early childhood was American military brat, and I lived in the 12 grades, first through 12th. I went to 14 schools.
And I was also a Navy brat as well, and I went to, I think, 5 or 6.
And approximately the same number of different households. So never had a home until I went to college, and at college, it's the first kind of permanent place I ever had. I went to the University of
I
California
didn't have as bad as him, but I understand.
at Berkeley, and I was not a good student. I was a poor student.
I didn't go to UC Berkeley. I went to UC San Diego and Claremont College and a couple of other places. I started college when I wasn't that great of a student, but I just wanted to get the computer stuff, guys. I was already doing computers from way when I was a little kid. I was 8 years old. I started messing with this stuff, maybe 10. It's a long time ago, way long time ago. And I just wanted to get that over with and get a job, enough to get a job. And that was just so difficult for a variety of reasons. But yeah.
I nearly flunked out, and then
I definitely
in upper division in junior and senior year and graduate year, I got good. I flourished, but it took.
Yeah, I had to get out of school and like get some kind of steady work where I had an income because I just had a recession hit when I was in college. I couldn't afford to go anymore, and it was just crazy. This the economy that's been going on. So I made another attempt after I had a steady job, and that's when it took off and it made it. I started to really understand how everything was put together.
Took a long time to get there.
Yeah, sure. Even though I started
You
early,
couldn't turn it off in those days. There were these monster computers that took multi-kilowatts of power, and they heated rooms, and it was dangerous to turn them off because they would break when you turn them off. So they kept them on 24.
I didn't know that. I didn't know they kept them on all the time. I thought they would make them break more, but I guess the heating and cooling, they found that breaks them down faster. So he found a little back door that most people probably didn't know that. Hey, if you're up here at 2 a.m., you can use the computer till 5 or 7 or whatever when everybody came into work. So, you mean I can get in there from at midnight? It's like, this guy's such a hacker, slacker. He's like, perfect.
7, and but they only had 3 shifts of work to do, 2 shifts of work. So they ran the computers from 8 a.m. to midnight, and then they were available from midnight to 8. Normally they just sat in a dark room, but eventually, through perseverance and just being around, I got a key and I could go in anytime after midnight and use it like.
How did he do that? By hook or by crook? He found a way. He found a way up that mountain. He found a way. Where is it? He found a way up the mountain. Where is it? Right here. Here's. Go here. This is what he did. He found a way. This was his goal here to get that computer. And he figured a way by hanging out and talking to the people to get up in here. Now this is for the ADD stuff. This isn't quite the same. But the idea that there's a mountain to climb, and there is a way in. There is a way in for people like him that are like dedicated, and this is what we're doing. So I'm going to make my life about this. Yes, there's always a way in, and he's just another little line of proof of this is how you do it.
Like a personal computer. It was, it's the size of a large house. Yes, I did. A teacher who became a very good friend of mine left Bell Labs to teach for 2 years maybe at Berkeley, and those were my years of graduating. And he actually enrolled me in graduate school. I didn't apply for graduate school at all, and he enrolled me, and so I had 1 year of graduate school, got a master's degree in it, and then he went back to Bell Labs at the same time that I was recruited by Bell Labs and went back to Bell Labs. And then at Bell Labs we were really good friends. We did a lot of collaboration kind of stuff. But then he left Bell Labs and
so they're in a club together. So the other people who are collaborating, trying to get the similar stuff kind of coming down the pike, because they're all kind of talking and they're all into it. It's not for the people that are into it. If you're not into it, this is just not going to be available. You have to be like super mildly obsessed.
came back to Berkeley and became a professor of I don't know what they call him, a mixed professor of mathematics and computer science. I avoided the recruiter because I just wasn't in the mood to go to work. I wanted to.
The slacker, man. He wants to play. He wants to do his stuff. He wants to be on his adventure. He doesn't want to go work for some damn corporation somewhere working on an IBM. He wants to change this whole thing to not be like he knows it's gonna be. So he's not exactly slacking. He's just like, no, I kind of want to keep working on this stuff, guys.
Just kind of hang around the university and be a professional student, I guess is the word. And he finally chased me down after a full week of interviews. You know, he came to interview all the students, and after a full week, he chased me down. Basically, I believe, but I'm not sure. On the recommendation of this friend of mine. The friend is Elwin Berlekamp, and he died just a year or two ago, which is a shame. And he chased me down at home. He came and knocked on my front door. And I guess he called that recruiting. And then I got a request to go and interview at Bell Labs. And I went, and again, not wanting a job at all, I saw the people there. And I was so impressed by the people.
And that's usually how it works, right? People who are on point about something that most people just have no idea. What are you doing, dude? You're just a professional student. And I was like, I'm doing this other thing, man. I can't really put words around it. I don't even have, maybe I don't want to talk about it. I just want to go do it. And you like notices other people, because that's like an A-level player, A-level game. That you're just to focus on the one thing. And if you see other people in that you can associate with and that are in that same phase, and you can recognize it, of course, when you see it, that's when things get like, oh, okay, this looks interesting now.
It was like home. I don't know how to describe it, but it was really
That was
easy.
your team.
And it wasn't a place where you worked. It was a place where you did what you wanted to do.
Somehow, some way, that the Bell Labs, they got situated in such a way at that time. They got enough trust, enough people, enough competency, and enough results already. Just be like, hey, we're gonna come up with some stuff, but we don't know when, we don't know how. We just need a little bit of money here and then, and kind of just talk amongst ourselves, and we'll show you stuff when we come up with it. And that's what they swung at Bell Labs for a long time, actually. And that is what is necessary. Management gets out of the way. It goes, okay, guys, we trust you. You guys have done some nuts. Don't have to explain it. We'll just run cover for you. That's what they did.
That's exactly what I was doing at Berkeley, except that I'd be paid for it. And so I said yes when in recruiting, and I lasted 34 years at Bell Laboratories.
Damn.
Yes, and that's part of what I was hired for. Multics is a big project, and it was over-designed and under-implemented.
That's that top-down stuff. Well, they know how to make a faster horse, right? They know how to make a double fast horse, triple fast. You put 5 in a row. They'll put double-sided, triple-sided. That's how you get more horsepower, not an internal combustion engine. No, it's a different set of fuel, a completely different technology. No, we're going to go with the multiple horses. Oh, okay.
I think it was destined to fail if it hadn't been supported by the government. The government was absolutely demanding a secure operating system.
So all these companies have been blown up in the last 15 years, pursuing just crazy ideas and just blowing money left and right. Where do they get that money? Zero interest rate policy. Giving out money for free. So we had this massive program of giving out money for free. And some of it worked, and some of it not working so good.
Bell Labs dropped out because it just wasn't fulfilling their expectation. But the government didn't drop out, and MIT, and it ended up with MIT and the producing it for the government. They'd spent a tremendous amount of money on it, and got nothing out of it. Absolutely nothing.
It gets me every time. They just that top-down stuff. It just doesn't work, man. You're just not gonna. You have to let go. You have to let go and let people like him who are obsessed with them. Maybe it's something a side thing, but it can be aligned with the thing. I mean, it can be also. But it's better if it's like directly the thing, and it combines all the things together that makes it an epic quest for people. Yeah. You need these kind of guys to do that stuff properly. Like, do you want something new, something different, something like you haven't seen before? You're gonna have to get these kind of this attitude.
And in those days, operating systems came with a computer, so there were no two operating systems from different manufacturers that had anything compatible, and so you ended up totally wrapping yourself around one manufacturer.
They call that vendor lock-in, and it's still with us today. AWS, Google's cloud services. You're going to pay money to get your data off it? What?
And we're stuck essentially forever. It was part of the way the manufacturers worked in those days.
Right. So that before these guys came around, these hooligans trying to play games on these things, that was all locked in. That was normal. That was expected. People groaned about it, but they didn't have any choice.
And they thought that was good enough because with the computer came hardware engineers and software engineers and people who would debug your programs for you and everything. So it was
That's a big sales cycle right there. That's a big money ticket right there. That's money on the company. That's money for the company. That's profits. Profits. Vendor lock-in, profitable. Especially if people have no alternative. Shh, don't make anything different. What are you doing? And Ken Thompson says, no, we can do, we can blow this thing up. You're thinking millions. I'm talking billions and trillions, man. They're like, well, what about our millions?
like full service for computing. Anyway, I guess part of what we did was change that model.
Yeah, you blew it up, dude. You blew it out of the water. Now, IBM is second rate. Bell doesn't exist. AT&T's gone. Yeah, you totally destroyed. And the thing is, these kinds of things are unstoppable. When the time is right and people are coming along, and there's enough guys like this all coagulating, trying to come up. This is the evolution, right? This is like, oh, you see one winner. No, there's a lot of just like people trying, giving up, trying again, coming back again, coming up again, blah, 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 all coming at the same, talking to each other, not talking to each other, trying to keep secrets from each other. And all of a sudden, boop, Ken Thompson, Dennis Ritchie comes up, boom.
We stole a computer and
Stole a computer. It's true. He did. Now, it was unused. No, but it was kind of probably going to be trashed at some point. No, it was older technology. No, it was like puny size. Is like nobody wants that. That's not big iron. That's not the big iron. Nobody wants that stuff. That's a mini computer. Ugh.
the operating systems work on it, and through that earned the right, again, but mostly by lying, by subterfuge. We were able to do what we actually wanted to do.
That's exactly so. He's totally adventure driven. Now, it was for good reason. They didn't rip these being flourished with his language, but I mean, they didn't have exact permission to do all these things. But hey, man, he's gonna ask for forgiveness. He's admitting the crime.
To do against
the thing is, we got UNIX and C and the whole kit and caboodle. We actually took computers from the ivory tower to literally everywhere, for good or for worse, for good, better for worse, whatever you feel about that. This is this guy.
Will of the company. And then when they found that we had what would today be called an app, the operating system was just something that supported the app, and the app was filing, maintaining, and editing patent applications, which is really Bell Labs' job as an industry. They're the research arm of the telephone company, and their job was to do patents. When the operating system, which was unsung, supported a patent documentation system, then we delivered that to the patent department, and then got our own machine based on that. And
so they proved their worth. They said, okay, look, here's how you do it. We'll make it for you. We'll put that thing together for you, but we want to do this other stuff afterwards. Okay. So, okay, because we're not getting it solved by any other way. The Multics thing failed. How much money did they pour into that thing? And how much money did it cost these guys to do it?
and it was off. We could do anything we wanted after that.
And that's what I'm talking about with this micro monopoly stuff. All the companies that you've heard of, all stuff, they have 2,000 services. 2,000 services at, what is it? Was it DoorDash? I was like, for food delivery, you have 2,000 services for food delivery. That doesn't seem right. So basically, all that software that exists out there is all technical debt. With things like KMP coming on and things where it refines all that stuff, you don't need to have 1 million people working on these damn things. And you don't need to have 2,000 services to do food delivery. No. I was working on a project called Returns, and it was like inverse package delivery. So instead of having your packages delivered, when you want them returned, you use this app to do it. It was one server, one app. It was even for the driver and the client. Now, I mean, it was an MVP. It wasn't scaled up, but it was just one app. What? One application? Are you kidding me? And it was 2 applications. You have the server, and you have the mobile. Oh, okay, 3. The mobile device for Android, mobile device for iOS, and the server.
No restrictions, no.
So my point, I guess my point is that there are moments in the computer industry. There's been moments like this, many of them, when all the old technology becomes almost obsolete very rapidly, and a whole new thing sweeps in and just wipes away all those giant corporations that were just through the land. Oh my God, you can't stop it. It's like, whoop, now we're down to a little size of a mouse. Overnight, like with just a few years, like boom, gone. These were mega giants, completely gone.
Recriminations, no nothing.
Yeah, so after he proved his mettle, he's like, they were like, yeah, okay, you do whatever you want.
Restrictions, no. Recriminations, no nothing. I'd started doing research on a disk scheduling algorithm, trying to get really high throughput through a disk on an unused machine that was just lying around. And slowly I had to build up the little pieces of an operating system. I didn't know it, but I wanted test programs to drive the disk. And so I had test programs. I had to store those programs on the disk, which is a file system. And then I had to run the disk, which is, with the file system. And basically it was an operating system, but it couldn't support itself. So I wrote an assembler and a loader and an editor, and then it could support itself. And that happened in a very quick time. But it was a realization that what I had was 90% of an operating system, and in 3 weeks I could turn it into an operating system, which for the first time was the actual goal. Before
3 weeks, I believe it. After all the stuff that he'd been through, all the programming that he'd done at that point, I bet you he already had it just ready to go. He'd already been working on it for years.
For that, it was a disk scheduling algorithm. Recruiting is a hard word. Basically, it was a fun machine, and I think all of us had our pet projects. Operating systems wasn't our goal. Our goal was to build something we could use to write programs.
Right. So they were trying to write games. They were writing games for their own purpose. And then in the process of doing that, they just happened to revolutionize the computer industry and write an operating system that we still use today. Just for games. That's adventure, man. That's the adventure-driven stuff, right? Oh, the operating system that will revolutionize this whole industry, that's a side quest. The main quest is the game. And playing it.
And Dennis and I collaborated on a program called Space Travel, that you push buttons to fly a little spaceship around the solar system. It had all the moons at that time, the moons that we knew. Right, things are different now, and with real-time gravity, real-time time. But there was an exponential knob that would double or halve the scale of the whole thing. And the scale, you could call it gravity, you could call it time, you could call it speed, whatever you want to call it. And basically you push that button and it's like, running the projector at twice the speed. And you do it like 10 times, and then you could go from Earth to Jupiter in a fraction, and then slow it back down and then orbit Jupiter and land or go to one of Jupiter's moons.
Now I have a theory, and if you made it this far through the video, you're going to hear a little bit of computer conspiracy. I think this guy actually might be extraterrestrial. I think this guy might come from another planet somewhere else, and he was just a visitor here to drop off a couple hints for you dumb monkeys about how to get some real computing power on and distribute it to people instead of this ivory tower bullshit. I don't know, but I've got lots of evidence.
So it was just fun, and it was a simulated floating point. The machine we used didn't have floating points, so it was and the algorithm was had to be, especially when you run at very, very high speeds. You're orbiting the Earth like once a second, and it had to be very sensitive about energy, and had to be fed back. Even floating point round off would destroy the energy in the orbit, right? And things would go wrong. So you had to kind of detect the energy and feed it back into the algorithm so that it was totally zero sum.
So it just didn't have the floating point precision yet. You didn't have the computing power to do that real time. So they came up with some different hacky little solutions that just worked.
And anyway, that's just on the side. So those are basically, and it was fun. It was a lot of people played it. Doug McElroy wrote a compiler called TMG. And then he wrote the compiler in TMG. So it was self-contained and self-reproducing. That's
some adventure-driven stuff right there. That's some high-level, like, woo! Looped, Inception-level stuff. Genius, of course. Genius.
On this horrible little machine. And I wrote in TMG a language called B, and then I rewrote it in B. So so you can think of each of these as a process. And then Dennis wanted to move B to the main comp center for all of Bell Labs and turned it into a real compiler instead of an interpreter. So he took B.
Oh, it was just an interpreter before that. Wow, okay.
And in the rewrite, we called it newbie, NB. He called it newbie. Now he's pretty much on his own. I'm alone. And he eventually started expanding the language. And then when PDP-11s came in, when we were able to get and move into PDP-11, brand new computers, B was just horrible language for that. It was a word-oriented language. You'd add words, you'd store words, you'd go indirect through words, but bytes were just horrible. If you had to emulate bytes, you had to end up putting a byte in a whole word or doing something very horrible. And so he basically put types in NB all by himself. He did that, and then targeted it towards the PDP-11. And at some point, in the meantime, the PDP-11 was Unix was written at that point, and in assembly language for the PDP-11. Dennis wrote the assembler for that, by the way. Then we got together and decided that the goal all along was to have this operating system written in the operating system language. And so we started with NB and put in all the stuff. Dennis did all the work, but we collaborated what features we want. And he'd come back with a running, program, compiler. Wow. And I personally tried to write Unix from scratch in this new language and failed. I failed twice. Just couldn't keep it all the pieces juggling in the air.
Yeah, because it was still a little too tied to the architecture, to the bite-sized architecture. So, but C introduced a type system, and that.
And then finally, in the collaboration between Dennis and I, he put structures in the language very similar to the way they are now. And with that, then I did the third rewrite, and it worked. I got it running. It was actually pretty easy when B became mature enough. That B, and then at that point it was called we called it C, and then C didn't actually it had newer features by and large, but the bulk of it was that original new B featured with structures finally.
And it's so awesome. It's definitely Dennis Ritchie naming convention. It was just A, then B, then C. It's so awesome.
And then it became our programming language for the PDP-11 for subsystems and more compilers and more loaders, more everything. 72 was the rewrite, yes, in from assembly language to C. And then after that, what has been known to become version 7, I restructured the typing system and the sharing system to be portable, what I thought was portable. And not me, but Dennis and Steve Johnson ordered a computer that was designed to be, its major feature was it was not a PDP-11.
Right. They're saying we're gonna make this portable now. We're gonna prove we've designed it all to be this portable thing where you've abstracted away. You're not doing assembly language anymore. You're doing it all in C, which is getting compiled down to assembly. It's like, okay, can we swap out just the assembler? Because it's Dennis Ritchie, right? He wrote the assembler. So if you just swap out the assembler, come in with C, but swap out the assembly code that's generated, and let's see if we can do that.
Okay, so that it would actually, that porting to it would be something, right? It wouldn't be just another name for PDP-11. And it was an Interdata 832, which was a very IBM-oriented computer. And then they successfully ported C and Unix to the Interdata 832.
And that blew it up. Once that was done, now so what he just did is he snuck the entire computer industry at Bell Labs, or IBM, that was all vendor locked in. He made an exit door.
And then portability took off. Everybody took a version of that and ported it. So
yeah, well, you just got yourself an operating system. Do you know how expensive those things are to maintain and deal with? And you wrote it in C, which everybody can just look at. And there's just one little component that does the assembly. And you can see how that thing works too. It's all open and you can see it. What? And Bell has no idea this is happening.
In those days, microcomputers, there were new chips announced almost monthly.
Yeah, because it was easy to. It was like copycat each other and just doing little incremental changes and stuff. It wasn't like every revolution every year. It was like, the revolution happened when the transistor was created, and it was just refinement after that. And there were stages that happened in the refinement that made it a lot easier. So with the CAD layout stuff that was introduced. Instead of just doing photographic, you were using computers to actually lay this stuff out. that blew it all up.
National Semiconductor had a couple. I can't remember. There were hundreds and there were tons of new chips, and every Silicon Valley company would take a new chip because the latest one was the fastest one, and build a computer around it, and then say, "Oh, now what do we do?" And they say, "Oh, we'll port UNIX." And
No, they had the plan to port Unix the moment they heard about it. The moment that you guys made that possible, they heard about it, and that's when they started pumping these chips out. And it wasn't like they got the chip and like, we'll look around. Where's the operating systems? Like, no, they're not going to create a whole chip for a computer without an operating system. So he's got a little confused. It's like, no. Once word got out that you could take Unix and you could make your own custom chip that you could then sell 1 billion of with inside of a custom machine, right? That you have some lock-in in, but it's based on this Unix thing. Oh man, they all went nuts. They went nuts.
And so these Unix clones came out by the dozens. And anyway, that's basically the story of how Unix got popular. Unix wars, but it was mainly
It was basically the same story as Linux. The same story as Linux. One guy figures out how to do this stuff, and he releases it to the world, basically for free. That was a mistake. Whoops. But the thing is, if it didn't happen that way, it wouldn't have happened, right? If it didn't get out free, somebody was eventually going to do it anyway. And it just happened to be these guys, and they did it pretty fucking early. This vibe was coming through anyway. This whole thing of like, no, you can't have an ivory tower because now that we have these little tiny chips, we don't have to have a big room. We can fit them on a desk now. You know, all that stuff happened, and they were just the big companies just were not. They couldn't stop it. They couldn't do anything about it, and they also didn't know how to like really take advantage of it. Now AT&T eventually caught up in the 80s, but by then it was already too late for them.
There was a long period of time in the 70s when computers didn't get faster. For some reason, you were just limited by the CPU memory interface.
Yeah, there was some breakthrough that happened in the mid 70s that all of a sudden the speed went up. But I think the techniques they got solidified for using computers to lay out the chips got more solidified. The number of layers they could do, I don't know exactly the technical reasons, but I know that I noticed it was like massive, like they were always getting faster and faster every year. Like you could count on it. Now it's slowed down, but
kind of the fastest ones were like a half a microsecond cycle time, and then after that, I assume it was semiconductor mostly in cache and algorithms. They started getting really fast. Like I remember, we were on a half microsecond machine, and suddenly there was a MIPS machine that came out that was 20 million cycles per second, right? And you can laugh at that now, but then that was a factor of 20 more than what we were used to.
And it was just enabled by the stuff these guys were doing. So that the fact if these guys weren't doing that stuff not would have happened. It would have just stayed stagnant. So there were these enabling technology things that happened just because guys were out there adventuring and wanted to play games. That's so crazy that people don't know. Like most people have no idea. They think, oh yes, the business, markdown charts, PDF, PowerPoint. We all know exactly we're the ones inventing. It's all these crazy dudes on their own, mostly on their own, just kind of going kind of half-cocked, not really playing by the rules all the time.
And so we switched to it. But every machine after that was faster and faster and faster. It was where Moore's law was applied to hardware and not software for a substantial period of time. The teaching, I ran away to Berkeley and taught for a year, and all of that was on PDP-11 written in C. And the John Lyons from the University of New South Wales made a 2-pamphlet book, 2 separate pamphlets. One was just a listing of the operating system with line numbers, and the other was a total description of how it fit together and worked, referring to the line numbers.
So that's badass. So they let him go off and teach. They probably had no idea what this was even going. And if they might have, but they didn't really understand. People are like, it's all coding. We're all talking about coding anyway. It's all computer stuff anyway. It's like this stuff right here. This blew it up. This was hardcore enabling that made all this stuff possible.
And that, I think, was the big teaching jump. After that, everybody I
Yeah, when you told everybody how it worked, it wasn't just a listing that only the super nerds are going to really get into it. But when you actually explained everything in a college course, holy shit, man. What'd you think was going to happen?
knew had a Xerox copy of those books. Well, those books were outlawed by Bell Labs because they
So they responded by outlawing it after it had already been released for a while. people were basing new hardware technology, just whole new computer systems based on this, and Bell Labs is cut out of the deal. You can hear the lawyers freak out. They did what? They're doing what? Put a cease and desist immediately. Press release to all the universities. And these people are Xerox. They're working with this old technology of Xerox. This is hilarious.
they're proprietary. It's basically a book of the source code of Unix, and so they restricted the sale of it to John Lyons and his students. So that was the original.
Oh, they restricted. Okay, they restricted. Oh, boy, that worked out real good, didn't it? Yeah, that's the other thing about too is when you got the people doing adventure driven, they're gonna be kind of going into regions that other people are all definitely looking at as well. And if you're not careful, you can lose your company by getting a little too cooperative. But maybe sometimes it's necessary, right? Sometimes there's a bigger thing happening at some other down the road that by you keeping your little holding on to it, that maybe that's not the best way to go at it, because we wouldn't have had all this stuff now. So we'd be still 20 years away.
Source that you go into the bookshop in New South Wales and get these books. You bring it home and Xerox it for your friends, and they would Xerox it for their friends. And some of these copies of these books were so out of proportion. They were twice as tall as they were wide as far as the fonts and things. But I think that was the big thing in education in universities.
Yeah, so all those people learned how to do all this stuff, technology they were working on. They all got upgraded, updated, and aware of what a real an operating system could be like. Now, I think these things have seen their day, but this is what we have right now. So this is what we got to work with. I want to see more of an Alan Kay. You can go look into this. You can go to my how to program from the ground up course, where I talk about how Alan Kay's what he's talking about there really kind of should be the way it is. But we got vendor lock-in all over the place. Apple wants you to vendor lock-in. Google, Microsoft wants you to vendor lock-in, and they don't really want to open up that stuff to let people really take advantage of the power that we have with these things. And it is kind of power user stuff anyway. So if you really want to get in there, you got to become a programmer, I guess. Okay.
We abandoned Unix at the Bell Labs, the Unix group, and we wrote a operating system called Plan 9 and some things like that, in a language that went with it, and we were off doing our own things, trying to change the form of computing. We wanted a totally dumb bitmap screen at home with no real computer in it, just one powerful enough to draw bits on the screen.
The early web, he's talking about the early web stuff. He was already thinking about can we have just little weak terminals at home and some big data centers someplace else? So he was already trying to do the web.
and then we'd communicate over slow lines, because that's what was available, to the computing facility. And we wanted the same language and operating system on both the computing, all three. There were kind of three big components.
Yes, we got it.
The desktop screen,
the
the terminal. There was the computing facility, which is big machines that you could just replace when a bigger one came, and a file system that they would all work through. And the architecture of Plan 9 was around that thing where you could work from home, pretending like you were on a high-speed machine in a big computer center over a narrow wire. And
so this was the 80s. They already had stuff like this running in the 80s. It was just the communications architecture wasn't available yet. We didn't have the high-speed data lines yet, because he was sitting on their ass, man. They weren't making it. They were installing it all. It's because they knew they were going to be toast once the microwave systems were all put up everywhere and the phone systems, people weren't making phone calls anymore. They're done.
And get massive file system, because most of the file system transfer was from the computer, the CPU machine to the file system machine. And so it turned out to be just really a great deal for the balance of power in computing at those days. Anyway, that's what we were doing, and you're off, inventing the world,
and nobody cared because it was proprietary and it was isolated, and it didn't get snuck out, and it didn't get out on its own, so nobody cared and it just died
through Silicon Valley. And
the stuff that he let go free, he's famous for. and lots of people made a lot of money. Unfortunately, Bell was not one of them, and he did all right. But so that's the thing, right? Once these forces are unleashed about adventure-driven development, and people like this get involved, it can change things, and it can change history, and can make things very unpredictable.
We were just in that. We were researching operating systems, and we went on doing other things.
Yeah. So that is an adventure-driven developer, and really inspiring guy. Out of the two, I do enjoy Dennis Ritchie a little bit. Work. I like his writing style. The way he wrote C was super refreshing. Very clean mind, very focused mind, and helpful for. It was a fresh change from the stodgy IBM and all their crazy ways they were putting all the very proprietary ways that they do things. It's very similar to what we've had today. So give me a like and subscribe, and I'm going to bed now. I'll talk to you soon. Bye.